I'm going to use this notation to represent 3D space, with the z-axis increasing towards the viewer. In all conventional overbalanced designs I've seen, the weight movement occurs on the same plane as the plane of rotation. The wheel rotates on the XY plane, and all weight or mass movements also occur on the XY plane. Suppose my wheel rotates on the XY plane. My pendulum moves at the top of a wheel and at the bottom of a wheel. In both cases, approximately on the XZ plane. That's a movement at the top, at the bottom. Also almost an XZ plane rotation. At left side of wheel, the weight is always closer to the axis than on the right side. If I take it to the other side, the right side, it extends, it's got more leverage. I've only made and attached one of my pendulums, but I did attach a fixed weight to the opposite end in order to compare the differences in leverage or torque. If we first compare the supposed higher leverage when the arm is extended and tilt the wheel just a few degrees to see what the torque does, I let the wheel go and there's no problem. The weight is picked up. If I repeat the same experiment with a pendulum in its other position and slightly tilted to the left, and the weight is slightly to the right, it cannot pick up the weight. So it, according to my observations, it has less torque on the left hand side than on the right hand side. It moves back up. Just to make sure, show you again, left hand side, a fixed weight, I leave it, the wheel goes back to the top, the pendulum goes back to the top. Move it slightly to the right hand side with the pendulum in the other position, I let it go, it lifts the same weight, no problem. I plan to experiment with an arbitrary number of pendulums of this type.